Hello, I am Julie, and here is my partner Evelyn. Today we will discuss the Mercury 2 Fulminate versus the Mercury 2 Cyanate. Hope you enjoy our presentation. First, we will start by the Lewis structure and formal charge. There isn't too much of difference between the two because they are anion isomers. They consist of the same compound with the same formula but different arrangement of atoms in the molecule and have different properties. They have same atomic number and same mass number but different energy states. Here we calculated the formal charge using the formula which is written here, valence electrons minus non-bonding electron plus bonding electrons over 2. For the carbon atom, we know from the periodic table that it has 4 valence electrons minus, it has 0 non-bonding electrons, we can see here in the picture, and it has 4 pairs of bonding electrons, which is 8. Because you can see 1, 2, 3, and 4 by 2 multiplied by 2, it's 8, and over 2, it gives us 0. The nitrogen electron has 5 valence electrons and 2 non-bonding electrons and has 3 pairs of bonding, which is 6 bonding electrons over 2. It gives us 0. And for the oxygen element, we can see it has 6 valence electrons minus, and the picture shows that it has 6 non-bonding electrons and 2 bonding electrons over 2. The formula gives us -1. For the mercury fulminate, the formal charge is calculated using the same formula. For the carbon 4, the valence electrons minus, we have 2 non-bonding electrons and 6 bonding electrons over 2 equal -1. The nitrogen has 5 valence electrons minus 0 non-bonding electrons and 8 bonding electrons over 2 equal 1. And same for the oxygen. So we will have the formal charge of C equal -1, N equal 1, and oxygen equal -1. Now, resonance structures. For the mercury 2 cyanate and the mercury 2 fulminate, they have 3 different resonance structures. The difference between them is the formal charge on each element. If we take, for example, the mercury 2 cyanate and the first one, the nitrogen has -2, the carbon has 0, and the oxygen has 1. If you see the second one, it's different. The nitrogen has -1, the carbon has 0, and the oxygen has 0, and same for the last one. And as well, we can see this for the mercury fulminate, that the formal charges are different. We can see here we can see here in the mercury 2 cyanate that the last one is the most important because the negative charge is on the more electronegative atom, which is the oxygen. Stability. Mercury 2 cyanate is stable. It has a negative charge on the oxygen atom and it has low formal charges. The mercury 2 fulminate is very unstable, and this is due to the having negative charges on the carbon and negative formal charge on nitrogen. It has also high formal charges. The carbon is the reason that makes the mercury 2 fulminate less unstable. As we can see here, we can see that the mercury 2 fulminate has negative charges on the carbon element. And here the mercury 2 cyanate doesn't have negative charge on the carbon element. We can say also that the mercury 2 fulminate is highly sensitive because it is unstable, which means it's highly reactive and it's highly explosive. Rule violations. Both of mercury 2 fulminate and mercury 2 cyanate violates the octet rule, and there's 34 valence electrons present. The octet rule, just as a reminder, it's violated due to the total valence electron being odd, or whenever a bonded atom has either fewer or more than 8 valence electrons. Now I will give to my partner to continue.
Okay, so now we're going to talk about the molecular geometry and polarity. So both cyanate and fulminate, they will be bent molecules, but the difference is that cyanate might have 2 bends, which we don't know if it's sure due to lack of information, but some sources say that they are bent. So the molecular geometry for both is going to be linear, and molecule will be polar, this one, and it might cause 2 bends to occur in the molecule on mercury and carbon. So mercury and oxygen bond have a difference of 1.44 in electronegativity. This is the only difference between the both cyanate and fulminate. So for fulminate, it's going to be bent as well, like I said, and it's going to be polar. It might cause 2 bends to occur in the molecule on mercury and carbon, just like cyanate, excuse me. And so the only difference here is that carbon and mercury bond have a difference of 0.55 in electronegativity. So that's the only difference between the two. So for physical and chemical properties, for cyanate, some physical properties are that mercury cyanide appears as odorless, tetragonal, crystals, or white powder. Its state of matter is solid. It is colorless, tetragonal, crystal, or white powder, like I said. And its molar mass is going to be 284.63 grams per mole. And some of the chemical properties that we found is that it's non-toxic in comparison with cyanides. It's insoluble in water, and its solubility is going to be ethanol and ammonia due to mercury, and it decomposes rapidly and emits into a large amount of gas. So for fulminate, some of the physical properties it has is that its molar mass is going to be 284.62 grams per mole, and it's going to be gray, pale brown, or white crystalline solid. Its density is 4.42 grams per centimeters cubed. Its melting point is going to be 160 degrees Celsius, and its boiling point is going to be 356.6 Celsius. And some of the chemical properties is that it's slightly soluble in water because mercury is insoluble. It's soluble in ethanol and ammonia. It's very explosive, so it's harmful. And fulminates are very toxic, about the same as cyanide. So both of them are very toxic molecules. So here we attach some of the references so that you can go back and read a little more about our molecules. And thank you for watching.
Thank you for watching. Bye.